homework, Cody. You know what I did?
Okay, no, we don't get another
5
section.
years.
Guess what I did? Because I was supposed
I
to.
didn't even know where it is.
Alright, hey, I'm gonna try to go through this as quick as I can. As we go through, I only have a select few problems picked out that I want to go through today. Once we're through it, I'm gonna give you your homework. You'll have plenty of time today to work. Tomorrow, we're gonna intro the next section, and then we're going to be looking at more time to work on that assignment tomorrow in the afternoon, like after we do a few notes. Because remember, I just intro. We don't go really far in depth that first day. We do that more the second day. But tomorrow, I want to give you some time to work on this. Test coming up is early, as early as the end of next week. We only have a few more sections. I think this first chapter is only it's 6 sections. We're halfway through it. Especially if these sections get simpler and simpler. Yeah, we're already halfway through it. So we're looking at a test. We're looking at a test probably at the end of next week. As early as.
I looked at the video from the first day last night, and you said that our first test would probably be homecoming week.
Yeah, that's coming up
Yeah, that's called a liar. That's a big 2 weeks.
So,
Exactly, so let's wait 2 weeks.
no, but
In this book, when it goes to section 110 is the 1.1, like the old book.
yeah, they do the same.
That's
Because
that is the same as 1.1.
I can.
Should be.
Companies Apple does with their
Apple does it.
No, it's not.
You should
Oh,
message
I
their
did not.
customer support.
All right, hey, let's jump right in. All right, first, let's go to a function. I'm gonna have you draw one right now. Here we go. All right, I want an intercept at -9. -9 on the x-axis. I want it to go up so that it's gonna bow up and it's gonna hit +4. So it's just kind of bowing upwards. And then it's gonna go diagonal down to -2.
This is a picture.
There you go. This is our picture. It's a very simple picture. I try to keep it so you know x-intercepts and whatnot.
All
right,
is this
so-
part of the homework, or is this just extra notes?
This is what kind of the homework looks like.
But it's not a homework.
Do I need a graphic?
So this isn't the
These
exact
are
homework.
really, these are really using today.
Don't worry.
Yes, you need to
What
grab
is
it.
the first part on the?
Okay, the first coordinate right here. First coordinate is -9 over. Then it's gonna bow upwards, so it's actually concave down, but it's gonna be concave down up to 4, and then it's gonna go strictly diagonal down to -2, -2, or sorry, 2, -2. Okay, so now when we start manipulating this graph using the transformation, we've talked about sliding up and down yesterday. One of the things I want to talk about is how do we go right and left? We did not do one of those yesterday. And how do we compact it? Horizontally? We did vertical stretching. Now we're going to do horizontal compacting.
So are we doing more than 2 graphs then?
What?
You said we're doing 2, but are we
2.
doing more?
2.
Like 2 extra after this?
Like this picture, and we're going to manipulate it twice. Okay.
3 times?
2. All right. So first one. The first thing I would like to do. So let's say this is my function. Let's call this f of x. Okay. The first thing I want to do is I'm going to put a f of x, but we're going to subtract 7 on the inside. So by putting it with the x, it's going to go to the right since it's negative. This shifts to the right 7 spots. 7 spots to the right. Now, why I know it's shifting to the right? They're putting the -7 on the inside with the x. So if we actually need the formula to this thing, you can plug the -7 into all the x's if you actually had the function formula. Because remember, this is just the name. When they do something like this, it's actually shifting it. So what this is going to do, so if you're going over to your new graph, so I don't know what picture you're on now, number 5 picture, I guess.
Right.
This thing is going to move over 7 spots from where it sits now. It's going to stay the same size dimensions, but all these major dots just move over. The x-intercepts have now changed. The y-intercepts have now changed. Because when you shift it right and left, up and down, it does change intercept values. So, like this x-intercept here was at -9, it's going to be coming over 7 spots, it'll hit -2 now. It's going this direction. So again, this should be on your new graph, so it's at -2 now. The top one, since it was at 4, it'll be shifted over 7 spots this way. Boom. So now that's at 7. What?
Do you believe in telekinesis?
Alright, so okay.
How do you make
Now,
that
next.
mean something?
Moving over 7, we're gonna go to 9. And so here's what the graph is gonna look like if we do this correctly.
That would be better.
Got it.
Now, you don't need those little red arrows. I'm just showing you that the whole graph is shifting.
That's like a parallelogram.
I drew one of those three check marks
Alright,
for the-
let me get rid of these arrows because that's kind of confusing. Alright, there. So there's your picture.
It looks like a
Hey, do we feel comfortable with right and left shifts?
Yeah.
It's like
Okay. Now, if they have negatives in it,
the
if they have negatives, the negatives will turn the graph over, like over either the x-axis or the y-axis. It depends on where you put it. So if you plug that value, if you put a negative sign out here, that's going to dump it across the y-axis. Like it's gonna be flipped all the way over. So every value will be basically inverted.
You see it?
So is it from the shifted or from that?
So it's from the original picture. So now there's an order to these things. So that's a great question. Do we do it from the one that we shifted, or do we do it from the original picture? It's a great question. So now, how this works is there's an actual order for how you're supposed to transform things.
sad man.
So there's an
10
order
dots, parenthesis.
of transformations.
First interroll.
That's an almond.
That's almost.
Some say porridge.
But still.
Alright, this order is something you need to have written down. In fact, I'm going to grab it out of the textbook here, just so I don't make a mistake. Because if I made a mistake, then I'm not going to do it.
What if, Mr. Ward, you should try to leave your book over there and move it to you with your mind.
Because you have the
Now,
force.
okay, alright, here we go. Okay, first one.
I have the reverse force.
Stop,
Mr.
that's
Ward,
not
want to grab
mine.
my pencil?
No, that's mine.
Reach just through it.
She's like,
Mr. Ward, no, no, pencil, reach the pencil. I didn't draw it.
Okay,
The force. Give me my pencil, Ward.
fine. Alright. Next, number 1.
no, it is.
Draw on the draft. Pencil now.
Well, you're
Well, you
crap
should
at
have
a
thought
lot.
about that before your birthday.
Okay, number 1. It's a horizontal shift. Okay, you have to do that first. We did that. We did the horizontal shift to the right. Second thing,
Well, this is my luck.
second step that you always have to do.
My mom thought it was
We're going to do a stretch or a shrink. Okay? So number 2, it's a stretch or a shrink on your graph.
Then it's vertical.
You can check the footage.
Stretch or shrink. Third one, you have to reflect. So to answer the question that Tyler you asked, number 3, if we're going to reflect, the reflection comes later. So what you're allowed to do, and it would still be the same graph, you're allowed to move it to the red spot where we have it now, and then the next step, since we don't have any growing and shrinking, we can reflect it, we can dump all the values across the x-axis.
What about vertical shifts?
Vertical shifts come last. That's the last thing you should do. Why? So that way, when you're doing all of these items, like you're reflecting, you're dragging, you're not accidentally moving it and then shifting it so it would go farther than it needed to go. So this would be a vertical shift.
Okay.
Can you say the first word?
Wait, let me make sure. Let me-
Horizontal shift.
I have it. I'll leave it.
All right. Does everyone have those written down?
Yeah.
Yeah.
What's an awkward term?
All right, so hey, to answer the question, this is my second graph now, the second last one. If you were to put the negative sign out front,
We're doing that one, right?
yeah, we're doing this one with the negative sign now. It's the same thing as my red one, but all the graph has now been flipped over. So this should be your final, what, 6th graph now?
Well, you just flip.
Yeah, so it's the same picture, but now we're flipping it. Now, when you do this, the x-axis, the x-intercepts, I should say, are not gonna change.
Ooh.
X-intercepts will stay the same because it's anything above or below the x-axis, those numbers are moving. Because you're not moving 0. Putting a negative on the 0 doesn't move it. So on this one, since I put a negative sign out front, here's what we're gonna do. I'm gonna put this in blue just so you can see this. This value will stay where it's at. This number goes down the same number it was above, so it's gonna look like this. And this number goes down to 2.
Wait, I thought you said it's on the outside of your y-axis.
Pencil, what I got.
Negatives on the outside goes across the x. It dumps vertically, all the y numbers change.
What?
So what you're looking at in blue, what you're looking at in blue, that's the final reflection. Because all the y values have changed to negative.
Can I go up to the board to
No.
count how many?
It's, okay, -2 over,
No. I'm talking about like the red one. I feel like I did it wrong.
7 over, 4 up.
I think I did 8 over an accident.
I wasn't counting, I just used the
Oh, what the heck?
You wanna see my graphs?
No, I
They
didn't.
probably started to do that. I can tell.
Alright, questions on the last graph we just did. Those are basically the ones I'm gonna probably ask you to do. I know there's the growing and shrinking horizontally. I wouldn't ask you to do something like that yet. Those will be coming later.
So this is just introduction.
This is just a slight, the easy break into it.
Positive.
We'll do the shrinking and stuff when we get to those sections when we need it. Okay, alright. Okay, my graphing's done. Graph paper, you can put that away for right now.
She was saying herself, the absolute, so I said the absolute.
Okay, hey, next thing, I want to do determine functions with composites. This is the part that a lot of people were kind of questioning yesterday. It seems a lot harder than it is. I'm going to try to do my best to explain it differently today. All right. Okay, this is the first one, and hopefully this makes sense. All right, f of x, we're going to say this is x cubed plus 1. Okay, let's say that this is my problem. And the question is, they want you to determine what the function was, like the original functions. There's 2 functions that they somehow put together to make a composite function, where they plugged one function inside of another one. Okay?
Isn't
Now,
there like multiple options?
there's more than one option to do this.
So how are you
But-
ever gonna check if there's like?
Because you'll have to go through
Okay,
the way
the
we
easiest
did
way
it.
to check is whatever 2 you give me, have to meet a certain stipulation where whatever you substitute in can't just be a plain x. There has to be something there, something
So you're gonna
substantial.
have to do a lot of work.
No, because all I have to do is take one and plug in the other, and if they work out to be this one, we're good. It's not hard. So here's the easiest way. Most people, when they first see it, they immediately know. This one's an exception. You'll immediately know what the 2 parts are.
Is it x squared, or x cubed, or x plus 1?
Yeah, so here's the idea. So this is the overall function. Can we stop? You guys are on camera. Because I can immediately submit that to the office and you can leave. Okay, so first part here. We have 2 functions that we have to somehow piece together. One of the functions, if you're kind of looking at this, will be the original one. What I mean by the original is like what they plugged into this. So I'm seeing this as 2 different things, and I think I already had a couple options on what this was. These are like basically, and I'm picking y, it's just random. These are the 2 things I'm looking at that they're probably using. Like these are the 2 main things. They have an x cubed, that's one of my functions. It's not just an x, it's an x cubed. And the other function was a y plus 1. And so what they did is they took one and plugged it into the other one, and somehow with these 2 mixed together, they made this thing, if you can see it.
Where did the y?
That's, the y is just a different letter, because I can't use the exact same letters the entire time. I can't use x's and x's again. Because it has to go into the other one has to use a different variable. So you can use any letter of the alphabet. So one of them can have x, the other one can have a different letter of the alphabet. But when you do this, they want to know what the original parts were. So obviously they're plugging this thing in here for the y, correct?
Right.
So the composite function is probably the h function with g of x plugged into it. Now again, where these came from, these letters, they're any letter of the alphabet other than f. Okay, I just picked 2 different ones. So those are my 2 functions, I'm plugging them in, and this thing, when I do this correctly, when I plug g of x into the h function, it should make that thing in the end. It should be a quick, I plug it in, yeah, it makes the same thing. Do you agree that plugging in x cubed in here for the y would make that? That's you determine what the function was. That's all it is.
That's easy.
It's easy. You just don't overthink it. Now, most people, when they see the problem, it's immediately, like you can tell instantly what the two are, because they're usually very, very separate. So let me give you another one. Like, don't overthink them. These are just meant to, you want to determine what the two functions are and write them down. So, let me get rid of this graph. Okay, so the next one. This is probably the most common sense one when you see it. Let's go with f of x. We're going to go with x plus 7 squared. Well, when you look at it, you can immediately see what the two parts are. Okay, one of the functions, I'll just call it any letter of the alphabet, m of x. M of x can be x plus 7, as you can see that in the problem. The other function, I'll pick a different letter other than m. Let's go
X
with
squared. X.
n. And let's use a y. This second function would be what the overall thing is, not the x plus 7. So it would be like y squared. Do you see that those are like the two main chunks of this function?
Yes.
The x plus 7 and then the y squared. So one of those functions is getting plugged into the other one. So what they're probably doing is they're probably taking the n function, this one, and they're plugging that thing into it. So that's m of x. It's written like that. So this is the composite function. This thing right here is going to represent f of x eventually. But these are the two parts that they're using to plug in to make the original one. That's what they want. So your homework would look like this. This would be problem number 31. They want to see this. They want to see what the two parts were, and how do you plug one into the other to make what they have on the page.
Is this action number 31?
No, I made that up.
Why would you do that to us?
Just to mess with you. So, all right. Questions on determining functions?
No.
Okay, the last thing here is to talk about inverse and symmetry. I think we finished yesterday with these, where they gave you your functions. They can either be a graph or they can be a formula, and they ask you, does it have an inverse? Graphs are very easy. You look and do the horizontal line test. Well, if it fails the horizontal line test, there's no inverse. If they give you a formula today, I want you to graph it on Desmos. So go to Desmos, type it in. So let me give you an example.
Are they gonna give us a formula?
They will give you formulas. So h of x, this is an x to the 4th plus x squared plus 1. So that's my formula. That function, you would graph it into Desmos, and maybe it looks something like this. Don't know what it looks like. Let's say it looks like that. Whatever that is, it failed the horizontal line test. So this would not have an inverse. That's all it is. It's a yes/no question. So on this one, there's no inverse because that horizontal line test hit twice. It's not. If it hits only once, you're golden. It has an inverse. So it's a yes/no question. Now, this would.
No.
This is a no. I almost wrote yes. This is a no inverse problem. No matter how you do it, if you switch the letters around, you can't find the inverse to it. Is it even, odd, or neither for symmetry, though?
Even.
This would probably be even, because it has even powers. But here's how you test it. You take the function, so that's h of x, and you plug in a negative x into it. This is your check that you do. You
If all
plug
the
the negative
negatives
x.
cancel,
Yeah, so we're going to plug the negative x in, so that's negative x to the 4th plus negative x squared plus 1. All the negatives canceled out because we have a bunch of even power, so it just goes back to this. And this turned out to be the original formula we started with. It didn't change. Even though I plugged a negative x in, that means I plugged all negative numbers into it. It turned out to be the original function, that's even. So this is even symmetric. If it's odd, everything will be the opposite. Everything will be negative compared to the original. And if one of the items is off, it's neither. It's not symmetric. Now if you looked at the graph, you can see that as well. That's why I said if you type it in decimals, it's kind of nice, because you can kind of see the graph to see if it's perfectly balanced. We talked about that yesterday. This is an even symmetric picture. The left and right side are perfectly balanced. If it was odd, the graph would look like this. It would be doing something over here, but it would do the complete opposite on this side. And neither would do something over here and different things on the other side of the y-axis. Questions, comments, concerns about even, odds, or if it has an inverse or not? You're not going to be asked to find an inverse. I'm not going to do that to you. That takes a lot more time. We're going to say that for a later date.
Thank you.
Thank you.
Okay, here's your homework.
Oh, wait, we didn't wait like 10 seconds.
Last assignment of the week. It's due Monday.
That's a quick turnaround.
Mr. Ward, probably not gonna be here on Monday.
On the
What day do you get back?
Do you think
Sunday night?
Sunday.
it's a rather quick turnaround for this homework assignment than we do on Monday?
Alright, here we go.
Tomorrow's a holiday.
Homework, due Monday.
Tomorrow's Tuesday day.
Now, if you are gone for the ag trip tomorrow, just know that we're gonna do introduction to the next section, work on homework, that's all we're doing. This one.
We'll be back.
You'll be back by this point.
Yeah, I don't want to stay up.
Alright. Page 26. Okay, now I'm gonna bounce around a little bit, so just kind of pay attention here. It's gonna go 1, 4 through 8, number 11, number 12, 23 through 26, 29, 30, 37 through 39. So I bounced around a little bit, try to pick out a couple problems where you had to find, you had to transform a picture by looking at the picture and kind of move it to a spot. If they ask you to draw, you do not have to use this graph paper. Okay, I'm not asking you to. Just draw a rough sketch what it's going to look like. It doesn't have to be super accurate. Just as long as you're showing me that, hey, it's going up 1. So you're showing that all the points moved up 1. Or if it's being flipped over, you're showing me that you're flipping the graph over correctly. Hopefully you had those steps, like the order of how you transfer, in case they have you do 2 things at once. But there's only a select few graphs. Most of the time they give you the original one, so you kind of know what they're going to do to it. Some of the problems, they'll have you do calculations. I think 80% of your homework today is doing these calculations for Composite. Plug one thing into another and just solve for X. Or plug it in and solve for what the number is. Something like this. Like this would be 80% of your homework probably just doing those things. Where you plug 2 into G and then plug it into F. So you can use a calculator and enter and just tell me the number.
Why do you think X is such a common variable in that?
I don't know. Okay, there you go.
Swag.
How you doing?
Yep. You are? Well, I guess you're
Jane, don't do it. I have a question. Jane, don't do it.
Question.
Do you believe in non-infinity?
But
Oh.
I didn't think that. Cindy, are you gonna get a book? What? Are you gonna get a book? Well, mine's in my locker and I don't really think he has extra.
Wait, it wants us to wrap on?
Lucas, did you bring your book?
No.
Did you bring your book? You don't have a book. Anybody bring your book that anymore?
It's just a student
What?
version.
Ward.
I don't have a.
Mr. Ward.
Mr.
Ward.
How did this end up here?
Thank you. Okay, Cindy.
No.
I did my homework in
For
class.
the first one, you're supposed to graph like 6 of them. You want like one graph with
Yeah,
like
just one
6
graph.
different colors.
No,
Like-
just do like 6 graphs. Like A is this graph, B is this graph, and just
So
draw
6 graphs,
just
not
rough,
one graph.
rough sketch.
Oh,
really?
Yeah, like
You don't need
one
numbers?
graph and then
I
you
want
said
just
six
compare
graphs.
them.
So like a crossing.
You're like, okay.
And it's like
Yeah, one
6
graph.
graphs. It's up a
No,
little.
one graph was 6 different.
You'll get it.
Nah,
Yeah, you'll get it.
No, he said 6 graphs.
Just looking on the right.
You want 6 middle
But
graphs.
he wants the bare
Straight up.
minimum.
I can show you after.
Yeah,
Oh, straight up, you don't owe me, Mr.
6
Ward.
tiny graphs.
actually this
Are you
pencil
gonna
I have over there, and this one, I'm happy with that.
That's why I'm skipping that one.
Okay, so first one goes to the left too.
Mr. Ward, you wanna see me draw fish?
Do you walk the whole?
How far should I sit down?
I just had some fun and I was very happy. One day.
Go up
Four. No, I'm taking number 4.
Mr. Ward, will you be celebrating the national holiday
You just leave your
tomorrow?
one
Which national holiday?
2K Day.
We have
Do the graph again?
Would you like me to draw a fish on your whiteboard?
Definitely not.
Is it acceptable if I do?
There's a graph again for the
Mr. Ward, you are still recording.
Say it again.
4 through 8 is graphing. On freaking line paper?
Oh, just on yours.
Huh?
I
It's
think
line
your paper.
paper.
Yeah, that's what we're saying, line paper.
You go to the right one.
Show our rest down.
Mr.
So-
Ward,
Oh my god.
Okay, but that many of them?
Mr. Ward, would it be acceptable if I drew
Yeah.
my
Seems
signature
that it
fish
goes
on your
opposite
marker
way,
board?
right?
Yeah.
Not acceptable.
Did you learn the homework already?
Marker board space and.
Hey, where do we find out what we need to answer in that?
Eventually.
I really
You guys have already proved I can't do it.
Yeah.
Derivatives.
I can't.
I don't know that plus two.
Hey, this is hard.
This goes
Not yet.
down.
It's just even remotely close to where.
I'm kidding again.
We're gonna make it past.
I can definitely know.
I can understand why that would be
I don't wanna do this.
Outline is what I did earlier today.
Can you go real quick?
Skills, one skill.
I'm just getting probably only
Yeah,
number
sorry,
like
what is that?
the rest of them are all
It's gonna take
fine.
some time to get
Down.
Mr.
Ward.
The y-axis.
Is this good, do you think?
I don't know how to do this.
Yeah, I haven't done it.
So if the negative sign is before the F, you flip it to the x-axis or
Yes.
y?
Yes. Because how I think of it is all the Y numbers are turning negative.
Just-
Where is my pen?
Are you gonna celebrate this as an all day?
First, then you.
When does it actually come out? Jeff,
What?
when does it actually come out? Tonight, like,
Okay.
right?
Tonight, for us, tonight at 11 p.m.
11 p.m. So
But if you
everyone's
didn't
gonna be
buy-
up all
no,
night.
if you didn't buy the early edition, it's not until Tuesday.
Oh, good thing I bought the early edition.
Nice work, Jaden.
Jaden, I'm so proud of you. You did so well. Mr. Ward, Mr. Ward, look.
I just got a minute more than that.
I don't really care.
Wait,
Mr. Ward, why do you still recording?
How'd you do that already?
It doesn't have to be exact.
Or good.
Plus two, so you just move two. So it's on left two. It's on the inside. The first one.
See you guys.
Okay. So it's actually zero.
Mr. Ward, can you turn over? Did I turn the camera off? Mr. Ward, I've turned it 4 times. Why have you not turned the camera off?